Oh, I don't want a crayon. I want to highlight it. Okay, so we've already talked about exact values. Exact values are not approximated decimals, right? So we leave it as, so root 7, you would leave it as root 7 because you don't want to approximate it. So the only way you would actually take a root and make an exact value is if it's a perfect square. So root 4, you would write it as 2 because that's an exact value. Root 5, you would just leave it as root 5 because it's not a perfect square, right? Makes sense? That's review from like grade, well, 10 and 11. If you have 0.3 repeating, if you have a repeating decimal, then it needs to be a fraction. So fractions are exact, but a repeating decimal approximation is not. So I don't want to see 0.3 with repeating. Okay, if you have that, you need to write it as a fraction. Okay, I know that's mean, but it needs to be a fraction. So for the angles of 30, 45, and 60, we can actually determine exact values for the ratios of sine, cos, and tan. And so you need to memorize these triangles. All right. The first one is the 45-degree triangle. So now if you have a 45-degree and a 90-degree, what's the angle at the top? It would be a 45, meaning what type of triangle is this? Yes, somebody said it. Isosceles. We have two, if it has two equal angles, it has to have two equal sides. These two sides could be any numbers. So we're going to make them 1, because that's an easy number. They can both be 2. They can both be 3. Doesn't matter. They're the same. Let's make it 1. Because all that matters is the ratio. See, if you had 2 and 2, let's say, and I asked for tan 45. You don't have to write this down, okay? Tan 45 would be what divided by what? Opposite over adjacent. What's the opposite? To y over x? Sure. So what's the y value? 2 over 2, which reduces to 1. If it was 3 over 3, it would still be 1. So all that matters is they're the same. And so the ratio will always be, for tan 45, it'll always be 1 because of those two equal sides. So to make things simple, we make this and 1 and 1. If I wanted to know my hypotenuse, because say if I wanted to know the sine ratio and cos ratio, I need to know r, how would I get r here? How did we get r yesterday? Pythagorean theorem. Man, that's a popular theorem, hey? What's 1 squared? 1 plus 1? 2. And so r is square root of 2. We're going to leave it as root 2 because is 2 a perfect square? No. Okay? So no matter what the sides are for this isosceles triangle, it's always going to be the ratio of 1, 1, root 2. So if the sides were 2 and 2, the hypotenuse would be 2 root 2 because everything's doubled. Do you remember similar triangles? No? Grade 9, if you have similar triangles, the exact same angles, the angles are the same, what do we know about the ratios of the sides? They are the same. So if this is 2 and 2 instead, what are we doing to each one of these sides to change it from this triangle to that? Multiplying it by 2. So what would be our new hypotenuse? Multiply it by 2. So it'd be 2 root 2. Okay? So when you have similar triangles, the ratios of the sides will be the same. That's going to be really important for today's lesson. Now we're going to use the most simple one because if I find, say, cos of 45 here degrees, you don't have to write this down. Okay, if I found cos 45 of this triangle, let's use this 45 down here. Cos is what divided by what? X over r, adjacent over hypotenuse, right? Ka, yep. So it would be 2 divided by 2 root 2. Notice what reduces out here. The 2's, right? The 2's are going to reduce out. So this would just be cos 45 equals you don't have to write this down. 1 over root 2. If I use this triangle, cos of 45 would equal to adjacent over hypotenuse. What would be the adjacent? 1 over root 2. Notice how doesn't matter. The ratios of the sides will always be the same. It'll always simplify to the same. That's the principle of similar triangles. We've covered that in grade 9, I think. Yes? Maybe it's a little bit simpler than this, but that concept is really important for today. Okay? So you need to memorize the most simple, the most reduced form of this similar triangle of 45 degrees is this guy here. Okay? You need to memorize 1, 1, and root 2. So that if I ask you to find what is cos 45 degrees, you can do that. Now this is what you can write down. Okay? We're going to determine cos 45, tan 45, and sine 45 as an exact value. Cos 45. Cos is adjacent, which is x over r. But we'll just do adjacent over we'll just do x over. Okay. So x would be, or your adjacent, 1 over root 2. Would we leave that ratio like that? What's wrong with it? The root's on the bottom. So how do I get rid of it? And rationalize it. Times top and bottom by root 2. And so this would actually simplify to root 2 divided by 2. Okay. Tan 45 degrees. That one's easy. What would that equal? Tan is y over x. So in this case it would be 1. 1 divided by 1 is just 1. And sine 45, sine is y over r. It would be 1 over root 2, because it's opposite over hypotenuse. And then, is that okay? Rationalize it. And we get root 2 over 2. Okay. Now the 30, 60, 90 triangle you can draw 2 ways. So this was the 45 degree triangle you need to memorize. You can draw it with the 60 degree at the bottom, or you can draw it with the 30 degree at the bottom. Okay? Would you agree though? Like if this is 30 degrees, what's the angle at the top? It has to be 60. So are they not going to be the same? Like are they not the same triangle? It's just flipped, like moved sideways? Sure. So if you just memorize it once, and then you can use SOHCAHTOA, you can get all your ratios. You don't have to like they're the same thing. Okay? So with the 30, 60, one thing we do know is we do know that if you type in, say, sine 30 degrees, we do have an exact value that we do know. Type that into your calculator. What does it give you? Sine 30 degrees. Type that in. 0.5. Is that an exact value? Sure is. How can I write that as a fraction? 1/2. Okay? So if we know sine 30 is 1/2, and we know that sine is opposite over hypotenuse, according to 30 degrees, where is the opposite? In this case, opposite of 30 would be at the side or the bottom? The bottom, yeah. I know you're like, how do I answer that? Kind of the x value in this case. And the hypotenuse, well, that's easy, right? Across from the 90. So in a 30, 60, 90 triangle, we know that across from the 30 degrees is going to be the 1, which is the smallest side. And the hypotenuse will be the 2. We need to figure out that other side. Okay? So how would I figure that out? Pythagorean. So I'd have to go 2 squared minus 1 squared, and then square root that. 2 squared is 4 minus 1 gives you root 3. 1, 2, and 3. Well, root 3. Okay. Root 3, is that larger or smaller than 2? Type it in your calculator if you're not sure. It has to be smaller, right? Because root 4 is 2. So root 3 is between 2 and 1, which makes sense because the smallest side is going to be across the smallest angle. So that's why the 1 is always across from the 30. The largest side is the 2, which is your hypotenuse, and then root 3. So when you're memorizing this, it's as easy as 1, 2, 3. Well, easy as 1, 2, root 3. Okay? Yeah, that's pretty cheesy. Okay, I'm sorry. I won't do it again. I apologize. Tough crowd. I need to come up with new material. Okay. So let's figure out cos of 30 degrees. So I can use this triangle or this triangle. It doesn't matter. We just have to use SOHCAHTOA, right? So cos is adjacent over hypotenuse. What would be the adjacent to 30? Root 3 over 2. Good. Is that rationalized? Sure is. And tan is opposite over adjacent. So what's opposite of 30? 1 divided by adjacent is root 3. Is there anything wrong with that? Root 3 is on the bottom, so multiply top and bottom by root 3. Okay, so that equals root 3 over 3. So can you figure out what cos 60 degrees is, sine 60 degrees, and tan 60? When you're done, just check up front. You get the same thing. A little later. A little bit. Okay, so these are the special triangles that you have to memorize. Now, obviously, you don't have to memorize what cos 45 is, because if you memorize a triangle, you can figure that out. So for any angle that has the reference angle of 30 degrees, 60 degrees, or 45, we should be able to figure out the exact ratio, right? Because using the special triangles that we have memorized. Okay, so you need to memorize these tonight, because your quiz is tomorrow. That's sorry, still short notice. Okay, so let's get going. Okay, so what are the 4 angles that have a reference angle of 30? So the first one would be 30. The next one would be 150, 180 minus 30. Okay. Next one, 180 plus 30. What's that equal to? 210. And 360 minus 30? 330. Okay. 45 degrees. All 4 angles that have a reference angle of 45. First one, all of them that have a reference of 45. 45. What's the second one? 135. Yeah, 180 minus. So 135. What's 180 plus 45? 225. And 360 minus 45 is 315. And then last are 60-degree angles. So all 4 angles that have a reference of 60 degrees. First one's easy. 60, 180 minus 60. 120, 180 plus 60. 240, and 360 minus 60, 300. So these are all the angles at this point that you can find the exact values for, the ratios, the exact value ratios, those angles. All 8, well, there's actually 8, 9, 10, 11, 12, because we could also find the 0, 90, 180, right? 360, 270. So let's try one, okay? So determine the exact ratio for 135 degrees. The first thing we want to do is draw it and figure out what quadrant it's in, which is 2. 135. The second thing we need to know about this rotation angle is its reference. We need to know its reference so we know which triangle to use from our memorized triangle. What's the reference angle for 135? 45 degrees. 180 minus 135 is 45 degrees. Can you see that okay back there? Make it, is that better? That's better. Okay, so our reference angle is 45 degrees. So we're going to draw in the 45-degree triangle that we've memorized. You probably don't have it memorized yet, but the 45 is the easiest. Because what do we know about x and y? They're the same. We make them what number? 1 and 1. And so what would be the hypotenuse? Root 2. Good. And at the same time, we don't even have to use CAS because we can put the signs in. In quadrant 2, who's positive, who's negative? X is negative, Y is positive, R is always positive. So now I can figure out the exact trig ratios for tan 135. Sorry, the exact trig ratios of 135. So tan 135, we're going to figure out cos 135 and sine. Okay. So first, tan. Tan 135, Rajveer. Okay. Tan is y over x. So that would be 1 over negative 1. So that reduces to just negative 1. Now I can check my work by just typing tan 135, right? Negative 1. There it is. Okay, cos 135. Cos is x over r, adjacent over hypotenuse. So negative 1 over root 2. Or if we rationalize that, what would that become? Negative root 2 over 2. Okay, so I can check that by going cos 135. Now it's going to give me a decimal, but I can type in negative root 2. Oops, that's not negative root 2. Divided by 2. Okay, are those the same thing? Yeah. Sure are. Okay, so last, sine 135. Sine is y over r. Y was 1 over root 2. We multiply top and bottom by root 2. Root 2 over 2. So again, if you want to check your work, cos 130, or sorry, sine 135. And is that the same thing as root 2 over 2? Sure is. Okay. So, oh, pardon me? To the right. Yes, to the right, to the right. Better? Okay, so draw 150 and figure out its reference angle. What's the reference angle? 30. So we want to draw the 30-60 triangle. Okay? So I'm going to make this a right angle right here. Carry that down. Easiest to remember when you're memorizing the 30, 60, 90. Remember it's 1, 2, 3. Across from the 30 degrees is always which value? It's the smallest side. It's the smallest angle. So across from the 30 is 1, hypotenuse 2, then root 3. Okay? Across from the 30 will always be the 1. Do I have to add any signs here? Yeah, the root 3 should be negative. So tan is y over x. Let's find tan 150. Okay, notice I'm writing my rotation angle. I'm not looking for tan 30. I'm looking for tan 150. The reference angle is helping me get the ratio, right? But the 150 changes the sign, because if we were doing tan 30, cos 30, sine 30, they'd all be positive values. Okay, so tan is y over x would be 1 over negative root 3, and I would have to do what? Times top and bottom by root 3. And I'd probably move the negative to like the side or in the numerator. We shouldn't keep a negative on the denominator. And so I'm going to put it in front or put it on the numerator. Negative root 3 over 3. Okay. Sine? What would sine 150 be? Nadir? Want to do sine? Y over r. What's your y? 1 over 2. Done. That's an easy one. Easy one to check your answer too. Okay, cos is x over r. So x is negative root 3 divided by 2. We're done. I'd like you to try the example 4. Okay, same idea. Draw on the special triangle, figure out the reference, draw the special triangle that's on the previous page. Across from the 30 is the 1, hypotenuse 2, and 3, root 3. Okay, so try this next one. How are we doing? Not great. Let's go back. Okay, so we're going to use our knowledge of exact triangles to figure out which angle it should be. So kind of what we did last day, except for we're going to use special triangles without using your calculator. Okay? So sine theta equals 0.5. We want to actually write that as 1 over 2, right, as a half. Okay? So first thing you have to remember is there's two special triangles. There's the 45s, right? 1, 1, and root 2. And then there's our 30, 60. Okay, this is a really bad drawing. I'm sorry. Across from the 30s, 1, 2, and then root 3. Okay? So we know that sine is positive, right? So just like before, we use cast. Where is sine positive? Quadrant 2 and quadrant 1. Okay, so we know it's going to be in quadrant 2. Oh, we'll go in order. 1 and 2. Okay, so we have to still use cast. We still need to get our reference angle. But we can use our special triangles to get our reference angle. So looking at this reference angle, if we know sine is opposite over hypotenuse, which angle would be opposite over hypotenuse give you a ratio of 1/2? The 45, the 30, or the 60? Opposite over hypotenuse has to be 1 over 2. Which angle has a side of a 1 on its opposite and a hypotenuse of 2? 30 degrees. Okay? 30 degrees, opposite is 1, hypotenuse 2. So the reference angle then is 30 degrees. So once you have these drawn on a piece of paper beside you, you can just look and see really quickly. And so now we can find the two angles. Notice my domain between 0 and 360, not including, excuse me, not including 360. So quadrant 1, what would be the angle? 30. Okay, so if it's quadrant 1, it would just be 30. Quadrant 2, is 30. Quadrant 2 would be 180 minus 30, which is 150. Okay, so let's try another one. Without using our calculator, let's find the angles. Now there's only one triangle that has a root 3 in it, and that's which triangle? The 45 or the 30-60? 30-60. Okay, try and draw 30-60. Let's try again. So 60, 30. Across from the 30 is 1, hypotenuse 2, and then root 3. 1, 2, 3. Okay, so cast. Where is cosine negative? S and T. But do you notice something? It only wants from 0 to 180. So it only is looking for the quadrant 2 angle. It only is looking for a domain of 0 to 180. So our solution will be in quadrant 2. Okay, so cos is adjacent over hypotenuse. Adjacent over hypotenuse. So what's my reference angle? Which angle would have adjacent of a root 3 and a hypotenuse of 2? And this, again, 30 degrees. Adjacent, hypotenuse. Okay? So that would be 30. And so what would be my quadrant 2 angle? 150. 180 minus 30 is 150. Okay? Here's my first step, second step, third step. Okay, the point 5 and negative 5 is on the terminal arm of an angle in center position. Without using a calculator, determine the reference angle. Okay, what quadrant would this land, this point? X is positive, Y is negative. 4. Okay. So it says X is positive 5, Y is negative 5. What type of triangle is this? 45. It had to be in the 45 because it's an isosceles triangle. Yes, one's positive, negative. That's just because of the Cartesian plane. But this is an isosceles. So what's my reference angle? 45. Pretty easy? That's an easy question. Okay. Next page. This is the example I've been waiting for. A 12-meter ladder leans against a building. If the ladder is adjusted from a 30-degree angle to a 60-degree angle, determine the exact value the ladder moved up vertically. Wait, let's make sense. If it goes from a 30-degree angle to a 60, it's actually moving down. Sorry, that's my mistake. Because 30, if you're at a 30-degree angle, no, wait. No, that's right. Yeah, you're right. I was right. I'm sorry. I did this, 30, 60. But actually, this is what, 60, this is 30. And we're okay. We're okay. So let's try and draw this somewhat. So here's my wall. Here's my ground. What do we assume about the wall and the ground? That's the wall is not leaning, that it's built true and it's 90 degrees. Okay? So the ladder initially is leaning at a 60-degree angle. Oh, thank you. Try it again. A 30-degree angle. Okay. Sorry for those of you who are writing in pen. I apologize. You should probably use pencil with me as your teacher. Okay. All right. So now we're going to take that ladder and we want to shift it up. Now ladders, it's still 12 meters when you move it. Sure is. So now we're going to make it 60 degree. And this is still 12 meters. What we want to know is we want to know this change in height, the exact value. That's a fun question. Now, if you wanted to do like grade 10 math SOHCAHTOA, you could totally find out that height change easily, but it would be a decimal approximate. What makes it tough if we want this as an exact value. Okay? So we need to figure out these two heights. Okay? Would you agree that if I found out, let's say this height for the 60 degree, and if I found out the height for the 30 degree, all I would have to do is subtract them, right? Okay, so let's talk about our 60-degree triangle. What is the, that's not what I wanted. What is the ratio? So let's draw a 60-degree triangle. What's the usual ratio of the sides? So across from the 30 is usually the 1. Hypotenuse is 2. And root 3. Okay? But that would work perfectly if our ladder was 2. But what is our ladder? 12. So that means I have to multiply all my sides by 6. So this would be times 6, and times 6. So for the 60 degree, what's the height for the 60 degree? 6 root 3. Okay, because the ratio, when you have similar triangles, if all the sides increase by the same multiple, you'll still have the same angles of 30 and 60. Okay, so we're just enlarging that triangle. So if I'm multiplying to make this 12, I have to multiply that side by 6, so I have to multiply all the sides by 6. Okay, so a 30-degree triangle. Let's draw the 30-degree triangle. Okay, across from the 30 is 1, hypotenuse, 2, and then root 3. So again, my ladder's not 2, it is 12, so I'm multiplying the 2 by 6, times by 6, and what would be the vertical height here? Just 6. 1 times 6 is 6. And so the height at the 30 degrees is 6 meters. Okay, so now we can say the vertical change. Oh, that is not how you spell vertical. I'm just going to leave that up there because it's pretty funny. There's an H in there I just threw. I don't know. I don't know where it came from. Sometimes our brains are funny. Okay, vertical change equals, which one's the larger height? 6 root 3 or 6? So 6 root 3 minus 6 meters is your answer. Take my special triangle and just multiply it by that scale factor to get the new ratios of the new sides. Okay? All right. This is review, the last question. write it down super quick because I want to end the lesson now. So just a review, if we want an approximate value, that's when we can use the inverse in our calculator. If we want the exact value, we use special triangles. Okay? So review really quickly. If you're looking for when is cos theta equal to negative 0.6753, first step is cast. Okay? So looking at cast, what quadrants would it be in? 2 and 3. C-A-S-T. It's positive in 1 and 4, so it's going to be in quadrants 2 and 3. Second step. Find your reference angle. And we do that, if it's approximate, not an exact value, by going inverse of the positive or negative? The positive. Make sure you're putting in the positive here. Because we want the reference. We want the acute angle. We don't want the first solution. So we grab our calculators. Second cos 0.6753. The nearest tenth of a degree is 47.5. Make sure, like when you're reading through, don't rush through a problem. Make sure you circle those type of things, right? Or underline. Because it's awful losing marks on written for rounding mistakes. It's just sad. Okay, and last we can find our rotation angles. Quadrant 2. How would I get it? (180 minus), which equals to 227. No, I'm added. Let's try that again. So that would be 132.5. Okay. Can't spell vertical, but I can subtract. Quadrant 3, how would you get that? 180 plus always. Which gives you the 227.5 degrees. So there's your two solutions. Okay, always double check your domain, because it might just be 0 to 180. So then it'll only be the first solution. Okay? We did it. We survived. So you have a lot of work ahead of you because your quiz is tomorrow. So you want to make sure you have your special triangles reviewed for tomorrow. You need to know or memorize. You have to have those memorized. This assignment you want to get done, there's 4 questions. 8, 11, 13, 2, 9, 18, and 29, 2 separate pages. Okay, yeah. Sure. And there's also some review you could do in your textbook. Okay. So if you were looking for more review, just go to the trigonometry, go to the end of the chapter, and just go through the sections that we've covered. So we've covered 2.1 and 2.2. So you can do any questions from 2.1 and 2.2 in the review section, okay? And I believe there might be some review on the website. I'll double check. Okay, so still have a little bit of time. Not as much time as I hoped.